Introduction to qualitative analysis. Qualitative analysis of both inorganic salts and organic compounds involve physical observation, physical and chemical processes that identify or determine the ions or functional group present in a given unknown compound. During qualitative analysis of inorganic salts, you will be provided with an unknown salt, and you will be required to carry tests to determine the cation and anions present. In a case where more than one cation or anion is present, it implies two salts have been mixed. Preliminary tests to predict ions or functional group present include: 1. Flame test. Most cations burn with a characteristic flame different from other cations, and therefore, from just the flame you can predict the cation present.
We're going to do a flame test on a number of selected compounds, primarily group 1 and 2 ions. And these are aqueous solutions, and we have just an inert metal loop. And we're going to dip the end into the solution and put it into the flame. And that excitation characteristic color is like a fingerprint for an element. So we're going to look at a number, and then we're going to ask you to identify some unknowns. Potassium. It should be a lavender color. This is barium. It's a green. This is calcium. Calcium. Sort of a yellow-red. Strontium. This one's a pretty red one. Lithium. Sodium is a bright yellow. And then the last one is copper. And this is the most vivid of all of them. Nice green.
For organic samples, aromatic compounds burn with a sooty flame. This might also be observed with high molecular weight hydrocarbons. Aliphatic compounds burn with a non-sooty flame. 2. Color and texture. The color and texture of the salts can be helpful in predicting the cation present, with the exception for the chromate anion, which gives salts containing chromates a yellow color. The color of most salts is determined by the cation present. Transition metal salts have characteristic colors, while non-transition cation salts are white or colorless. The texture, whether crystalline or powder, might also be helpful, although this can be affected by storage conditions of the salt. Most crystalline salts are hydrated, and once they lose the water of crystallization, they may become powdery and their color may also change, so do not rely on just texture and color to confirm the cation present. 3. Solubility in water. The solubility of the salt in water gives a hint on the likely ions present. For example, if the unknown salt is soluble, perhaps a nitrate is present, and if insoluble in water, perhaps the salt contains silver and a halide ion, and you can confirm that a nitrate is absent since all nitrates are soluble. Refer to the solubility table for the whole list of soluble and insoluble salts in water. Chemical reactions require a liquid medium to react. In simple words, two solids mixed together may fail to react, but once in solution, the possibility of reacting is so high. Therefore, sample preparation is key. Qualitative analysis reactions are mostly carried in test tubes. Usually, one spatula endful of the salt is dissolved in about 5 to 10 ml of distilled water, and the solution is divided into aliquots, that is portions. If the salt is insoluble, some can be dissolved in a mineral acid. In this case, do not mistakenly include the anion of the acid in your results. Testing reagents can then be added to the portions. Rule 1. Strictly follow the instructions in the procedure. Rule 2. Use the right quantities, that is about 1 ml of the analyte solution, and 2 to 5 drops of the testing reagent. And if instructed to add excess reagent, then add twice or 3 times the volume of analyte. Rule 3. Do not discard the test tube content until the end of the practical. This is important since some reactions are slow, and thus, the initial and final observation may be different. In such case, record all the observations. The last and important rule 4. Do not attempt unauthorized experiments.